All right, so this is the last example for graphing absolute value functions. If you want to look at the previous videos or the previous examples, go back to the previous videos. All right. In the previous videos, we did use a table of values to graph the functions. So this time we're going to look at vertex form. G of x equals a times absolute value of x minus h plus k. That's in vertex form. So when we graph g of x, this equals -2 times absolute value of x minus 1 plus 3. You can see that that's in vertex form. So we're going to try to graph this without generating the table of values. And then we want to describe the transformations from the graph of f of x equals absolute value of x to the graph of g. All right, so we can quickly graph this. This is our parent function. We know that the parent function has a vertex at the origin and is a V-shaped graph, just like this. All right, so we can go ahead and label that as f of x. That's our parent function, and that's what we're going to be describing the transformation from. So let's make g of x red. That'll help us tell the two functions apart. All right, so if we want to graph g of x, we can do that by using the vertex. So the first thing we need to do is say that hk is our vertex. So it's got negative h here, so -1. So h would be 1, and k would be 3. So 1, 3 is our vertex, over 1, up 1, 2, 3. All right, so that's our vertex. And then we need to find a point to the left or the right of the vertex. So let's just choose 1, 2, 3. So let's just say, let x equal 3. All right, if x equals 3, we're going to plug in 3. 3 minus 1 is 2. Absolute value of 2 is 2. 2 times -2 is -4. -4 plus 3. -4 plus 3 is 1. Wait a minute, -4 plus 3 is -1. All right. All right, let me check that again. So 3 minus 1. 3 minus 1 is 2. Absolute value of 2 is 2. 2 times -2 is -4. -4 plus 3 is -1. Okay, so now that we have another point, so we can come over to 1, 2, 3, and go down 1. We know we have another point. Now we can reflect this point across the line of symmetry. So you know that x equals h is the line of symmetry, so I can come over to the line of symmetry and go 2 in the other direction and know that there is a reflection point there. So that is a quick, easy way to graph if it's in vertex form. So you have to find the vertex, find another point, and then reflect it across the line of symmetry. All right, now if you want to describe the transformations from the graph of one to the other, from the parent function to g of x, all right? So the negative, we know that the negative is a reflection across the x-axis, so that's why the g of x is turned upside down. So that is a reflection. We know that the 2 is a vertical stretch. Okay, so that 2 makes it a vertical stretch there. So this is a reflection. This is a vertical stretch by 2. And then we know that this is a horizontal movement. So we have a horizontal translation of 1 unit to the right. And then the plus 3 is a vertical movement. Okay, a vertical movement up 3. So you can see by the graph, you can see that the vertex shifted to the right 1. It went up 3. It reflected, so it's upside down. That's why this is negative. And it has a vertical stretch by a factor of 2. So you can see this one is not quite as wide as this one. All right. That is all for graphing absolute value functions. Again, if you want to use your calculator to check yourself, you can always type this in and graph it. It's a good thing to look at this just to make sure that you did everything correctly. So if you want to go to y equals, and then you can just type in g of x, so -2, and then math over to number, ABS. So x minus 1, and then come outside your absolute value and do plus 3. And again, if you hit graph, you can see that graphs your g of x. Again, if you want to check certain points, you can go second table. That generates your points. You can see that 1 is over 1, 3 is your vertex here. And you can check points on each side of your vertex. All right, that is all for graphing absolute value functions. If you have any questions, please let me know.